Ooh, startup hackathon.
How much time do you waste every day? Are you frustrated by load times? Is your creativity hindered by the amount of time it takes your tools to load? Why do we even have secondary or tertiary bootloaders? Do you even need an operating system? This hackathon, we set out to be different. We set out to save time for the entire world. We wrote Solitaire in the bootloader. Writing a bootloader in general has a lot of technical limitations, which I won't go over the entirety of. But some of the big ones that we ran into are having to write the entire program in 16-bit assembly, requiring that the code be very small, including code and data. In fact, the code must live within 512 bytes, which is one sector of a disk. And in fact, 2 of those bytes have to be used for boot signature, so we only have 510 left. The system's running in real mode, so we have no memory protection, and there are limited tools available to do our job. Additionally, writing an assembly requires pretty detailed knowledge of the x86 architecture. The entirety of the game state is stored in 118 bytes. 104 of those bytes are used for the cards, 52 cards times 2 bytes per piece, to store things like the suit, the value, whether the card's shown or not, and what the next card in the list is. The remaining 14 bytes are used to represent the piles in the game, the suit piles, the draw and discard piles, and the play piles. Here you can see a screenshot of the game board visible in the QEMU emulator. In this side-by-side video comparison, we'll compare boot to Solitaire on the left with loading Solitaire in Windows on the right. The first set of videos in side-by-side is running at 4x. The remainder of the video, which consists of the Windows loading, runs at 8x.